Hello and welcome to my guide on calculus. In this video I'll be talking about derivatives and covering most of chapter 3 in the textbook. Along with this video I've also made some notes over here, I guess handouts. So I'll be scanning those and putting them in the Google Doc, and we'll add them to this description. So I guess if you need some help understanding, feel free to look at those. I worked pretty hard on them. So anyway, on to derivatives. In chapter 2, which was about limits, sorry, this camera's so bad. You should have frequently done something called the instantaneous rate of change, where you find the limit as h approaches 0 of f of a plus h minus f of a over h at a certain point. So that is pretty much the exact same thing as taking the derivative at a certain point, because the derivative, it's basically just the rate of change or the slope of the function. There's absolutely no difference at all. Just to give a real world example, say if your basic function is a position function, say in physics, the derivative would just be the velocity or the rate of change, and the derivative of your velocity would be your acceleration or the rate at which your rate of change is changing. So it's really not that complicated. Yeah, but anyway, this is a formal definition of a derivative. It's not that hard to remember. So I guess just an example of differentiating or taking the derivative of a function. I just use x squared right here. So yeah, I just wrote down the formula here, and since the function is x squared, you just take the x plus h and the f of x and square it. So I have limit as h approaches 0 of x plus h squared minus x squared over h, and just doing algebra to just FOIL out the x plus h squared, get x squared plus 2xh plus h squared minus x squared over h, and you the x squareds cancel out, of course, so yeah, we're left with 2xh plus h squared over h, and since there's an h in every term, sorry, that's ridiculous. Yeah, since there's an h in every term, you can cancel out the h's here. So it's just 2x plus h, but since it's a limit, as h approaches 0, it's just 2x. So any point in your function, x squared, the slope at a certain point will just be 2 times the x coordinate of that point. And in addition, that was what we call the formal definition of a derivative, in case I forgot to mention, which I might have, but there's also the alternate definition of a derivative. So this is saying that the derivative of a function at a point is this right here. Sorry. The limit as x approaches a point A of f of x minus f of a over x minus a. I don't think you'll encounter this as much as you will the formal definition on like tests in the AP exam, whatever, so I'm not gonna do an example of that in the video, but I'll probably include one of them in my like handout notes. So yeah.